Oh. All right, my friends. First, just a little word. Notice we are having, it's more of a quiz tomorrow. Oh, that's physics. Okay, maybe I need to write that for math 1. Math 1 quiz. Quiz Friday. Okay. A little bit of Pythagorean, a little bit of distance formula, and a little bit of the chapter 10 stuff on bar graphy kind of things like tables and bar graphs and stuff like that. Okay, so a little bit of quiz tomorrow. A lot of time tomorrow, hopefully in class, is the plan to work on your slideshows and your how to take your data that you're getting from your questions and put it together into some of the charts and plots that we're looking for on that stats project. All right?
Yeah.
Yeah. Are there questions on the homework packet before we move into today's stuff? Was that?
My Dr. Scholl.
Yeah. Was that grown something about the homework packet, Brody?
He said no.
Oh, he said no? I couldn't tell what that noise was. All right, so let's take a look first at the side. Let's see how to distinguish it. But what you can see here is we have the y and the x, and so the points are all in the first quadrant. So there's 2 sides to this sheet. Find the side that I'm on. Okay, because this side has x and y in the middle. This side has the y over to the far left and x at the bottom. Are you on the same side as I am?
Yes.
Okay, here we go. Find the distance between the points. Yesterday we looked at some people who lived in a town where we had streets kind of lined up like this. We started to look at how you could find a diagonal distance. Okay, by looking at how far apart coordinates are this way from here to here, and how far apart coordinates are this way from there to there, and using that information to ultimately help you find this distance. In that distance formula, we ended up seeing that y2 minus y1 squared. How can I help you?
Extra paper?
Oh, yeah. Okay. y2 minus y1, that's the distance from here to here. For the side where they're different in the y value, in order to figure out how far apart they are, we can look at y2 minus y1. Okay, if I'm looking at the ordered pairs for these 2 points, they're both at x of 3. Here's 3, they're both at 3, so the x coordinate is exactly the same. The way they're different is one is down here where y is 2, and one is up here where y is 6. Now these are small numbers and everything's positive, so we can easily see how long that little segment is. How long is that segment from here to here?
4.
4. because it's starting at 2 going up to 6, or I find out how far they are by saying 6 minus 2. That's the difference between the two. And what we just did with that is say y2, 6, minus y1, which is 2. So part of what we're going to do in this particular triangle, and I'm not writing with a nice FFA pen there, thank you, Miss the FFA crew that's out there, is I'm going to go 4 squared. How I got that is I looked at the difference between the two y's, and what that's given me is the length of this side, plus, now on this side, they both already have the same y. They're all at level 2. Anywhere along here is 2 up from the x-axis. The coordinates for this other point, P1, are, let's see, they're going to be at, how far over is P1? 5. So the x-coordinate is different than the x-coordinate over here, but it's at the same level. This 2 and that 2 match. So if I want to find out how far apart they are, this one's at 5, this one's at 3. How far apart are those guys? 2. I can find that mathematically by subtracting them. 5 minus, x2 minus x1 is the generic formula. And so this is going to be 5 minus 3, which is 2. 2 squared is what's going to go in right here. What we're trying to get at is,
Letter C.
we're trying to get at C. What we're looking at is a way to use Pythagorean. Pythagorean, a squared plus b squared equals c squared, to find a diagonal distance. And a way to do that, if we don't necessarily know these two sides, like I drew in the triangle, but all the other ones that you're going to work with don't necessarily have a triangle drawn. And you don't need one. But what you can recognize is that on one leg of the triangle, you're looking at how the y's are changing. And on another leg of the triangle, you're looking at how the x's are changing. But you're really working with the right triangle, and we're doing a squared plus b squared equals c squared in a different way. Okay? So to finish off this, 16 plus 4...
C equals 4.47.
Square root of 20, 4.46. Okay, that was a long answer there. Let's take it in a little bit abbreviated fashion. I'm not going to draw in sides this time. I am going to focus on coordinates, though. Coordinates will be helpful as we move to more complicated triangles or points on the other side. What's the x and y of this point, P1? Yes?
Isn't your answer supposed to be 4.47?
Oh, I don't know. Brody told me. 7? Okay. Thank you. Did you say 7 and I heard it wrong? I'm sure it's my fault.
It's okay, it's a point. It's a point something, so it doesn't matter.
Okay. Here we go. What's the x and y coordinate right here at P1? 1, 3. What's the x and y coordinate right here at P2?
6.
Okay, that's the first thing that you need to know how to do. The second thing, distance formula. I drew in the triangle last time to try and make it easier to see what's going on, but the shortcut is what we were really doing on one side is looking at differences in y's, and what we were really doing on the other side is looking at differences in x's. Those differences gave us legs of a right triangle. Here's what we're going to have now. I'm going to take 4, subtract 1. The two x's, 4 subtract 1. 4 minus 1. I'm going to take 6 subtract 3, the two y's. I'm going to take 6 subtract 3. 6 minus 3. The differences in y's gives us one leg of a right triangle. The differences in x's gives us a different leg of a right triangle. That's a squared and b squared. Okay? And what you're ultimately trying to find, this would be the hypotenuse if we drew in a right triangle. And that's c squared, which if we want your c out, you take a square root after you're done. It doesn't matter who you're using in the front. Like I went 4 minus 1. But once I go 4 minus 1 and make this the front of the subtract, that's what I got to do the same way with the y's. Make the x's and y's match up in that way that this point started the subtract, this point starts the subtract. And you can choose, you just have to, whatever you choose for x's, do the same pattern for y's. Okay, 4 minus 1 is 3 squared. 6 minus 3 is another 3 squared. 9 plus 9, square root of 18. You can leave it like that or pop it into your calculator. What do we get? Could you do it in your calculator? 4.24. Okay? All right. You go ahead right now, do the bottom two, and then we'll look at the other side together. How many minutes is that?